Welcome to our first technology exchange with the topic, what is gRPC? I hope you will enjoy the presentation, and maybe you have some ideas on your own that you would like to share with everybody. Then definitely hit me up and let's talk. Maybe you could be the next one who is speaking, but let's see how I do it first. So what is gRPC? I can imagine some of you already have maybe Googled about it. So gRPC is language agnostic, high performance remote procedure call framework. G stands for general use and RPC for the remote procedure call. But I guess the best way to understand it is to see through some of the examples, which we will really go into later, because all of this language agnostic and high performance stuff and this like remote procedure call doesn't like ring a bell right away. But too long didn't read of that situation is that you have a microservice, we call that the server, and you need to communicate with that server. For that, today we are using REST, and you make the request through the REST to the server and you get the information back. With RPC, the difference is that you don't have to build a client or the server part. It will be generated for you. And that is arguably one of the bestest properties it has. So essentially it feels like you are calling methods on your own code, but actually they are being executed on the server itself. We will see in a second. So let's go forward. Why are we even talking about this gRPC? In the microservice world, it is considered at the moment the alternative to the REST in service-to-service communications. Many big companies have started adopting it. As you know, the technology is really influenced by the big players in the market. And that is also the reason, I guess, why Google open sourced this. So in 2015, Google open sourced gRPC. I think they have been using it since 2010. They have like inbuilt this. And I think when they open sourced it, they started working together another big company. Spotify actually had something really similar already built in, but as it seemed to them that it is easier to take in an open source way of doing communication with microservices, then they also have adopted that. When you Google alternatives to the REST microservices, then this is the stuff that I see. Maybe you get a different result, but don't use REST for microservices. Okay. Adopting gRPC as an alternative to REST. Is REST the best microservice architecture? Protobuf alternative to the REST microservices. So protobuf is actually part of the gRPC. And I will show you a protobuf example later on as well. Lots of like new terms that initially maybe do not click right away. So we also will go through a few examples, and they will get harder. But bear with me, I guess. So gRpc benefits. Why are people talking about it? It is modern, high performance, lightweight framework. It's contract first API development. So we will go into this right away after this slide. So using protocol buffers by default, allowing language agnostic implementations. So essentially what it means is that your team may use one technology and my team may use different technology, but we are not wasting on our time trying to make these technologies communicate with each other by writing clients or servers that are able to serve information. We are preparing the information to the API level itself. So we are preparing the interface. In your world today, it is Swagger essentially. You open the Swagger, you see information, and that is the contract that server offers you. So it offers multiple different languages to support, like pretty much all of the popular languages are covered by gRPC. And one of the most interesting things I think it offers is streaming. So what that means is that both clients and servers can stream information with each other, and the data like is transferred like bits by bits. You're not blocking the request. It is like continuous flow of information from server to the client, or from the client to the server, or both ways around. That is also a possibility. And it is the information is compressed together because it's serialized in the binary format. And actually, I would say that is really not because of the gRPC itself, but because the thing that it's built on, and that is HTTP2. So HTTP2 offers something interesting that HTTP1 does not offer, which is multiplexing. So let me show you an interesting GIF I found on the internet. So essentially what happens with HTTP1 is that we make a request to the server, we get the information back, what is available on the server for us to download, and this is in one TCP connection, it's one connection. And now we have to make that many connections of how many new files we need to access. But with HTTP2, we don't need to make new requests at all the time. I mean, new TCP connection, sorry, request we still make. Also, one of the benefits that HTTP2 offers is the header compression. So for every HTTP request we make between the servers, we need to provide the necessary information like cookies, agents, and so forth. However, if we send this information repeatedly, it is useless info. It is the same in HTTP1. Like if you have the same session open, you don't need to pass this information like probably more than once. So with HTTP2, it is reduced, and it's also compressed together. And like I said before, HTTP2 is sending information in binary format, and it compresses information really well. And also data loss is a bit harder to achieve there, one key benefit. So gRPC is based on HTTP2 mainly. So let's go back to the topic, contract first API development. So this is a really interesting concept, what comes with the gRPC. And maybe let's straight jump into this ticket I have here. So I created a dummy ticket for us. I have it somewhere over here. And now we actually see what is this proto buffer as well. So we have a ticket in order to support asking customers information. I want that we implement a new API for the customer information retrieval. And now we have some gibberish here. What is this? So this is the gRPC API description, essentially. When you want to communicate with servers, you need to know how the information is served. So today with REST we have Swagger, right? So let's take, I have some example Swagger stuff here. I have a get request here, and I can pass in some information, and this is the data that I expect back. So this is what we are used to right now. But with gRPC, like with this protobuf that it is using, we have to actually think about the model first. So that's why it said contract first. In order to get this outside of the REST, you kind of need to already write the code to get to this point. You cannot really see this interface that we are having right now without writing line of code. But with protobufs, we are designing the interface first. And I have watched some of the talks from Google and some other companies as well, but Google, some ex-senior guy told that actually senior developers are spending the most time on the phase of API development, and it's actually really hard. But let's look what is this thing that we see here. So we have message customer request. It is having something int32 customer ID equals 1. Then we have message customer response. Seems like it is going to give us back first name, last name, and then we have service, customer service, and a method name, get customer, that is taking in an argument and giving back us the response. So it seems that the customer request that we have here is going to be the argument of this method. And the customer response we have here is going to be something that this method is going to give us back. Now, protobuf is strictly typed. That means that when we are defining our interface or the API or however we want to call it, you have to write properties, attributes with specific data types kept in mind. So this is an integer, this is a numeric type. So it will expect always numbers in this request. Why this number 1 is here? That is something that is protobuf specific. In order to serialize all of these attributes that are present in the interface, it needs some sort of like index for them. So when it makes the interface into the bytecode, then I guess these numbers will start like representing these values. So one number cannot actually repeat itself in the same message. So you have to go 1, 2, 3, 4, 5, and so forth. Some of the numbers are, by the way, served as well. So what next? We have this proto file. What we can actually do with that? Like I said, we really don't need to write a line of code to have a client, right? But how is that really possible? So let me show you. Let's go to the server first. I have created a microservice called Grpc server, and I'm going to show you how we are going to implement the server part of this application. So let me show you what we are going to do in the end. So this is going to be the end picture of what we are going to do in this demo today. We're going to have a microservice 1 that is having Grpc client in it and REST API. The REST API will execute the function in Grpc client, and then it will make a request to the server, and the server will retrieve the information from the staging database and send us back the answer. So this is the request we are going to make from the Grpc client to the server, and this is the response that the server is going to give us back. The reason we have this REST here is that I need a way to execute Grpc client. So it's like on a handle for me. This in real world is not really necessary, but in order to demo what I need to do, then this is what we will use. It will make more sense in a second. So let's go back to this Grp server. So at the moment I have somewhere in random place in code, I have created a class called Grpc CRM controller. I have also included here some service that I have already written. This is a constructor for our code. But before I write any line of code, I want to show you that I also have this, let me move this Zoom stuff. I also have this proto file in my code, right? So I have this customer response, customer request, and now I'm going to generate some code for myself. Let me actually close down this application. So generate. To you, it seems like nothing really happened, but I already know that behind the scenes, there is generated API folder that got filled with new data from us. So it created this custom request, it created this custom response, and it also has the implementation for the client and the server already built for us. So let's go back to this controller. I will also show you this code in a sec. Actually, I can show it right away, but it's really hard to understand. And I would say this is one of the minuses of this framework. Later on, I will also line it out. So it auto-generated for us tons of code that is pretty much this server and the client functionality that we do not need to write on our own. But we need to understand how to like create the necessary components. I mean, doesn't like really help if it sits in a random place. So since we are using Java, there is this thing called Grpc Starter kit, and it offers us this funky annotation called Grpc service. And that way we don't really need to set up this Grpc server with some manual work, and it kind of does many things for us. So there's lots of like manual things you need to do in order for the Grpc to even like work on a specific port, because it's not automatically started. There's nothing magic happening here. So it does the preliminary work for you. If you define that this is a Grpc service, then it will attempt to start a Grpc server and start listening to it. But anyway, now we need to extend functionality that was auto-generated for us. So we have customer service implementation base. So this is the class that was generated for us from the proto buffer file. And it's an abstract class, and it implements this function get customer, and it expects a request and a response. So let me show you in the proto file, get customer, it's this request and response, right? So let's go back. Let's create the method for us. And this is it. Our server is ready. Done. Let's go home. So let me run it and show you if I actually make a request here against how can I even make a request here? That's also a good question. So Grpc has started on the server port 9090. And I have a client for this. So previously I did some testing, so there is previous output. I make a request and it's telling me unimplemented method, get customer. So it's not there yet. But otherwise the service itself did not break and no errors. Interesting. Life goes on. So I guess next step would be to have something here. Let's try to give an answer. So as I already know that I have some helpers built for me that request information from the database. So I have this method that goes to the database, and now it should take in a customer ID that I have. But where do I get the customer ID? So I get it from the request. Get customer ID. You may be asking, okay, but where did it get here to this request, to this custom request? It is this customer proto. This is the REST. I mean, sorry, not REST, but this is the customer ID that is being passed in. Not this number one though, but this value is undefined, but it will give me it from there. And I know that it will be integer. If I try to go in here, then you don't really understand what's going on here. So not a beautiful sight to see. But anyway, I can understand from the proto file. So we pass into my service that here is the customer ID put to this customer entity all of the information you have about this customer. Let me show you the customer entity. So the customer entity has first name, last name, full name. So this data will be filled. Now I need to give back the information from the server. So let's do customer response. Response equals customer response. And the interesting thing is that Grpc auto-generates you builder patterns for the data transfer objects. So we set first name, customer entity to get first name, we set last name, customer entity get last name, and build. And now we need to pass this response back to the client. So let's do response observer. This is the second parameter that gets in on next response. So this method is essentially to stream information back to the client. Always when you have info, you call this. And when it's like everything is finished, all of the execution for this function is done, then we call onCompleted. So this is necessary because sometimes maybe you have this block of code in a for loop and you get constantly new information and you can send it back. This is called streaming. We are not at the moment streaming, we are just sending it one go. So let's do a restart to the application and see what happened, what's changed. I think the application is up. Now I'm using this client that I have, making the requests. Awesome. So this is a Bloom RPC. This is some client, open source client that was written to directly communicate with the RPC server. You cannot use there is no Swagger for it, essentially. You need to use some tools. There are quite many of them. I will later on show you that not all of them are awesome. But anyway, these are the customers we have currently in staging. And this is the information we are getting back from the server. So we did not really write any lines of code for the server itself, right? So pretty much we only focused on mapping the information to the response and retrieving the information. This is what we did. So that is what is called implementing business logic. Everything else was done for us. Now, we still have the other part of this thing to be done. So we have REST API somewhere that is calling something, and it should call our server. So let me show you this REST API. This is not this. This is the correct one. So I have at the moment running on port 80A081 another microservice, and this is the one that is supposed to connect to the Grpc server, and this is the REST client for that. So if I currently do execute here, I get back static first name, static last name, static full name. Now, this is not by accident. I actually made it on purpose to behave that way. So let me show you. Essentially, this method here, get customer by ID, this is this REST call that was made. It's going to execute this method with this customer ID that we get in. And it's just setting the data. It's essentially not doing anything here. I'm going to stop the server now. So only thing that what it is doing is that it's setting this data as default and returning it right back. That is all there is to it. It's not communicating with the Grpc server right away, but we need to change that. So let's change that. But first we need to see that also in the Grpc client, let me show you that I have two different projects open, right? The other one was the server. This is the client. You can imagine both of them being microservices because in the end of the day, we don't name our services clients. So I have this customer response and customer request also defined here. And maybe this time around, I have already kind of created it beforehand, but I will delete it. So we have this generated API, it's empty, right? Nothing is there. So now I'm going to generate the code from the proto files, and blam, here it is. In the CRM, I have also loan here. That is another example I have, but we're maybe looking at that later time. So customer service Grpc, lots of interesting code here, hard to understand. So we need to implement this in our client part pretty much. So let's go to the customer service we had open before. And we are also using in this microservice, this Spring Boot starter for the Grpc. So they have created an annotation for us, Grpc client. Here we have to define the application properties that is corresponding to this, let me show you, corresponding to this client. So I have written lone localhost, even though right at the moment we are asking customer data, not really lone data, but don't let that disturb you. So we have defined in the properties that it will retrieve this information from localhost and the port that I had my Grpc running in, and other settings that may be necessary for it to run. So let's implement the client. So we have this class defined by auto-generated from the proto file. So customer service blocking stop. And with this, we can make a request to the server. So let's build the request object. So we already saw before the Grpc will, like with this generated stuff, it will use builder pattern. So we can set the customer ID, and the customer ID will come in from the method here. I have created the request, and now let's have the customer response. Let's write it, response equals customer service blocking stop, get customer, and request. And now we can write here response get first name, response get last name. And we don't seem to have anything for the full name. So let's see. So no full. I have some interesting other methods that it has auto-generated, but no full name. So let's leave this as it is. And we will still return the customer DTO that we set. But now the data that comes in here comes through this customer service blocking stop. Okay. Then let's execute the service. The service has started. Let's go back here. So this was the REST endpoint that we previously used. And it returned static last name, static full name. And now it is returning us Phil Brakus, static full name. The reason for the static full name is that because we don't have it there. But let's say we want to have it there. Now, what that means is that we need to change the proto file, right? We need to add it here as a new parameter. But just for the sake of it, let's not do it on the client side. And let's do it on the server side. Let's see what happens. So let's write here string full name equals 3. It will be with the index 3. And let's stop our server. Let's generate our code. Let's go to the place where we set the stuff. Now, I already know that it exists here, this full name. So set full name. So now we have officially updated our, oh, whoops, wrong task. We have officially updated our API. We have added one extra attribute. This is a really normal thing that happens with APIs from time to time. New stuff is required, right? So let's go to this place, this client we had. Let's make a request. Let's see what it gives us. So it's still giving us the first name and last name. And you may be thinking, why is that? The reason is that I'm using a different proto file there. So if I change this proto file to the correct one, let me see if I can do it really quickly. So I have somewhere over here, Grpc server, main proto, CRM, customer proto. So what does this have? Does it have? Damn, it still doesn't have it. I wonder why. I don't really know the answer for that, because this is what happens if you're using some new tools. And I would say that is the downside of every new technology that you're going to face, is that errors like this will happen. You don't really understand. I just like implemented this, but it's not really there, right? But I can assure you that it definitely is here. On this server, if we have the correct proto file to make the request, we will be able to retrieve the full name. But for the demo purposes, let's go to the UI back where we were before, and let's see if anything breaks here. So the client is still working. So that means that the client did not break even though the server has changed for us. So that is a good benefit of this proto buffers, is that you can add new fields and attributes, and it will not necessarily break the existing services. So this is actually a good thing, because you can decouple yourself with the changes from other teams and services. But let's try to get this working on the client side. Let's see if I will manage. So in the client side, I will now also write full name equals 3, and I will do the generate proto. So I will generate the necessary classes. And now the response object should have get full name, unless the full name was never set for that customer. That would be also interesting. Let's see. So let's run the client again. The full name should be present here, and yes. So the service has started. Let's see what happens. I see. So now the full name is here, right? But with this thing, either I'm too stupid to use it, or it's buggy. And that's definitely a bad sign if you want to implement something new. Maybe we have some time to take a look at a bit more complicated example. So usually when you watch these demos about gRPC, that's what you see. They're using like these really easy things. but life is not easy. At least in my experience, life is quite hard when you start implementing.
So, can I interrupt?
Yeah.
What happens if you remove a field rather than add a new field?
You mean if I remove like the first name or last name, or which one you mean?
Yes, exactly. Any of them, and the client still has them present.
Okay, that's a good question. Let's see. So let's go to the server. Let's remove the first name. Okay. Let's regenerate our stuff. And we need to remove this as this no longer exists. And let's restart and let's see. Now I already know that our client is probably not going to behave as we expect it to, but let's see. So we're not going to do any changes to our client side. I'm surprised. There is no error. Are you disappointed?
No.
So on the client side, it just doesn't have this info, but it is capable of retrieving the other one. That is a really interesting way to test it. I did not do this test myself. I only tested it the other way around, adding new stuff, but not removing. But what I can say is that definitely what can be a problem is that when we now add back something different here to the server part with value equals 1, then it's going to use the same index as this first name, and then definitely there will be a conflict. So if you're going to remove something, you cannot use this number again in that message. You can use it in other messages, but not in that one.
Well, it would be renaming in that case.
Yes. Yes. So,
Miko, is there any chance you know, like, do you have an example of how this structure would be serialized?
No, unfortunately. It's not human readable. Thank you for asking that question. That is a very good question. That is a key thing, and maybe we can move to the next section of this. And if you have more time, I can look at the stuff that I have more written. But Justas asked, how would be the serialized like object? What can I see? And with gRPC and with REST 2, I mean HTTP 2 in general, is that the data is not human readable. Definitely not with gRPC. Maybe you can make the HTTP 2 run in plain text mode, but gRPC data is not human readable. So it is definitely one of the downsides of it. I can also add harder to test stuff if you do not have good tools. So let's say you implemented a new endpoint or new API. You want to test it out, then you are left with tools like this, and there are some others as well. Actually, you can use it through Postman as well, but you need to do some stuff to get it working. You need to create a proxy that is capable of reading that information from Postman to gRPC. And that proxy is like open source, then you can use it, but still it would be good if you could just use Postman without any of the tricks. So there are, like with every Hollywood character, there are like the times when you have to witness its unperforming choices in life. So I would say there are also things that are not so good about gRPC. One of them is what we just discussed. You have to get used to like new stuff essentially. Is that with REST we are really used to the fact that everything is really accessible in reading format with human eyes. You don't need any like super tools. but with gRPC, that is definitely different. Also, what I have noticed through building these applications is that when I'm browsing through the code as a software developer, what I really like to do is that I can jump to this object that I have here, right? This data type. So if I jump to it, I can understand what is going on. This is really important. With gRPC, with the generated code, then it is not necessarily the case. So if I jump to this custom request, so what do I see here? I see garbage. Probably if I read it for maybe half a year, I mean, I get used to reading this, then I'm capable of picking up the data with my eyes faster. But I would really like that if I want to jump into this, I actually would be jumping into this one, because this is the information I like to have. I like to see the data model. I don't care about the implementation. I want to see the data model, but maybe that is just me. I find it highly annoying. But definitely, if it was me, I would create myself a plugin that would solve that problem. So not a big deal breaker, something you have to work around initially, like with every new thing. As I already mentioned, auto-generated Java, really hard to understand, at least in the beginning. It's like put all together there and doing God knows what. In real life, complicated protofiles are complicated. So this was something I wanted to show you guys before. So this can be actually your future here. So this is not anymore that beautiful, right? When you have new first name and last name, this is quite hard to understand what is going on here. If you look at it like from the bird view, you need to take the time to read. So what I have done here is that I have created a request to get all the debtors who are like in depth in specific or code and how many there are of them. And here's the response for that. It is going to give me the currency, the account ID, and the debt amount, and which org. So I would know which account is in how much debt. And there's another debtor's response. Okay, what is this? Well, it seems that this thing is used inside this thing, and it has this keyword repeated in front of it. So that means that you get the list back. You get multiple responses back. So not necessarily a bad thing per se, but I'm just trying to emphasize that when you're going to design APIs, you have to do it really well, because otherwise this is probably not a good example what I have done here. So you will be ending up with a mess that is hard to understand, and you need to make correct decisions as soon as possible. Also, there is a possibility to import other protofiles. So I was thinking to myself, do I really need to rewrite the org codes every time with each new proto? Seems like a redundant thing. Turns out you don't have to do that. You can do it in one place and import it to other places. So this is actually quite awesome that IntelliJ already has good plugins that you can use, and it formats gRPC and proto buffers, and gives you the good formatting of the data. And also it tells you if you're doing something wrong here. Also, I saw that maybe I do not trust this int32 because I'm dealing with money, right? And I want to be sure that every decimal point is counted, but there is no big decimal. So I had to create my own. I had to create a new data type for that, which you can also do. So I created big decimal to the message format. So this one I could use to send information. But the downside with that is that when you will get this information back on the front end part, you do not really understand what you're reading there. By front-end part, I mean, let me see if I can show you. So I have somewhere this REST loan controller. Let's do max results. Let's do 100. Let's see if it's even working right now. So this is really easily to understand, but let's do the portfolio part. Interesting. I think I have it on the other service. Do I have it here? Okay. Okay, I'm not going to search for it because it will take too much time. Essentially, what I wanted to show you guys is that when you're creating your own kind of data types, then it is not always easy to understand what you're reading when you get the response back. Yes. So this is quite complicated RPC already. It has only like 3 services. It is offering stream functionality, and in a sense that is really cool. Let's see if I can demo that to you in a second. So I have this, we don't have much time, but this is something that I find so interesting. And then we can go on. So this is another part of the code implementation for another service that I have created, loan service implementation base. I'm not going to walk you through this code, but you can already see that it is getting complicated, right? It is not the same anymore as it was with the first name and the last name, because life is complicated and banking is complicated. So if you were going to choose gRPC, then you have to face the fact that the mapping part of the like implementation is part of your life. There are mappers for Java as well that are capable of dealing with simpler data mappings from one object to another object, but not always. So sometimes you have some custom stuff going around. But anyway, I think this is the one where I think this one is the correct one. So let's do an interesting thing here. Let's do one and let's do something stupid. So I have a list stream debtors in organization, and let's also do I have a logger here? I don't think I have. I think I do actually. I think I have log. One cycle complete. Let's see. So let's do a restart here. Stop and rerun. And on the client side, we should also have something that is calling this. Maybe it's easier to search it from here. So I have this thing here. Let's also, okay, I'm already outputting some information here. So I'm going to show you streaming, gRPC stream events for contract. Okay, let's see. So where do we have the client? I think this was the client. No, this was not the client, the other one was. Okay, so let's call out this 100 and maybe 100 results. Let's put LV. So what you can see is that this is now loading. Nothing is happening. You don't see a response here. That is what would happen if you were using REST. Let's go to the service level. So let's look at the logs, what is actually happening here. So this is the client. The client is at the moment receiving information after each second that the server has processed. I made it artificially, right? So I put thread sleep and cycle complete. And when cycle is complete, it will send information with this to the client. And now the client can already process this information. And still when you go back here, this is still waiting because the full batch is not ready. And that is the difference with streaming information and just getting it in one go. I think this is something that we don't really have in Java that much in use anywhere. And with grpc, this is already built in. You don't really need to think about that. It is a functionality that you can use when you want it to be used. So this is awesome. Going back to the slides, as I said, real-life protofiles are complicated. Also, let me show you what happens if you try to open the file that I created. So let's go to the proto, loan service proto. Opa, error while importing protos. No such type enum org code. So welcome to the life of open source world, where when new technologies come, your tools are really not up to the complicated tasks. Definitely there are tools that are better than this one, but I thought it's an interesting example to share. So pretty much what it means is that we have quite complicated protobuffer file for the loan, and the tool is even incapable of parsing that, even though I have written it in standardized way. So I'm not breaking any laws. What is unexpected. Lots of mapping is necessary. So it is like you need to connect two pipes always. There is no one stream coming to your service from the server really easily all the time. Sometimes it is very easy. Sometimes you could use a mapper. By mapping, I mean pretty much when we get the request and we get the response. And now for each response, I need to map it back to the other object, perhaps. Not always, but in the end of the day, if you want to serve it somewhere, then you most likely don't want it to be in the same way that it was before. So mapping is part of your everyday life then. One of the most, like, I guess, unexpected things and different, like, requires different way of thinking is the way the protobuffer file is behaving with its default values. So you can have strings like you saw before. Actually, I don't. Yes, you saw. So with the first name and last name, you're using a string. But if it's not filled, it is automatically assigning empty string into it. For bytes, it's empty bytes. For booleans, its default is false. So you cannot make your system depend on that unless you design your system in a way that it is expecting true, otherwise always false. For numeric types, the default value is 0. So I don't really know what to do about that one. But definitely you can work around it, but still imagine that you have loan interest, and when it's not set, then it's 0. Doesn't seem like a good situation to me. So you need to kind of work around such cases. You need to design your contracts in a way where this is not a problem. And it also supports enums, which is awesome, but the first defined enum value will be default, and it always has to be 0. That's not a really big issue compared to other ones. But these are the things when you're designing these protobuffers, you have to keep in mind. So today we took a look at this, that you have this REST API making a call through grpc client to the grpc server, and we get the response back. And we did a simple example with the custom request. And later on, I will send you guys an email where you can access the source code and see it for yourself in your local machine, because I think it is always better to look at the stuff on your own. Then you can also go into this loan services, which I have built here, and see what is going on, because there's lots of code here just to map stuff. So it would be maybe interesting for you to see different ways. I have done the streaming part. I have also done the part where you send a list of information back without streaming it. So you can see different ways how to use it if you so want to. So I have been talking now. We had some questions before. Maybe we have some more questions at the moment. So any questions, feel to ask.
How complex is the authentication thing? Obviously, you need to somehow restrict who can execute which procedures and functions and so on. So how easy is this implementable? Because you didn't mention it. I know that is there, but
yes, that is very good question. That is a bit more complex topic. It doesn't mean that I'm not going to give you an answer, but what I'm trying to say is that authentication is already built in. Not at the moment in my example, but Grpc supports all sorts of authentications, and also the Spring Grpc boot starter. Now depends which one I land on. So I think it was the Yudoman one. It comes like with a good documentation for the Spring security, and Grpc also offers like all sorts of interceptors. You can essentially build a system where quite easily, where you intercept a specific HTTP header and send it to a different place entirely. You can do all sorts of stuff like that, but you can do it already in Spring as well in Java. But yes, I did not really cover that, and it is there, Jan. It is there.
Yes, I know. I read the documentation. I just wanted to know, I mean, your impression, how easy or how complex it is to implement and how it actually looks like. But I got the impression. Thank you.
Yes, I haven't really had the chance to go on to that next level. I would say that it is not definitely really hard, but it's definitely something that is not super easy as well.
Do you see any other advantages of using Grpc compared, let's say, to RAML and generating the classes and so on from RAML code, except streaming? Is there anything else like the benefit?
I would say the communication part within the process of defining the API. I think that is something that will save companies some time and money. Also, I have not had the luxury to run the tests on OKD, but lots of benchmarks show that Grpc, since it's based on HTTP2, is significantly more performing, like better than HTTP1. And the performance comes when you start making like 15 sequential requests. That's when the rest starts to decline, but Grpc starts to shine. It is not degrading at all. So if you have really heavy load microservice, let's say, actually I can't give a good example, but yeah, so those are the cases I see that it is really beneficial.
I just wonder, of course, it's somehow handled, but how the load balancing is actually accomplished, because if there is a streaming or HTTP2 go, so if something falls on the back end, some service dies and some other one has to take it over, how transparent it is for the client side, so to say that. In REST, it's simple. One request is lost and that's it. But here, I mean, this communication is like ongoing, and something is lost, how it actually works out and how it's like, how the system handles it. I'm pretty sure that OKD with current setup cannot handle it at all, because it's like one request and response versus doing it in this way. There's a big difference.
Mm.
But yes,
what balance load balancing. I have seen that there are like multiple articles about how it's implemented on the client side and how there are like some setups around it. So it's definitely a topic in the gRPC world, but I'm not an expert yet on that matter to give insightful information. So I can tell you that if you are interested, then you definitely will find lots of answers. So like lots of smart people already have covered the load balancing part as well.
Yes, probably is. I was wondering if you maybe know something about it, but yes, okay. It's too much to ask for the beginning. Thank you. We have to leave entirely at least the room because some other meeting is coming up here. But thank you, Miko, very much.
Okay.
Okay.
But I will stop sharing. And if you have any questions, discussions you want to have, we have this flip chat as well. You can post questions there. If I know the answer, I will answer you. And I also will send maybe today or tomorrow a survey, so you can leave me feedback. What did you think about the presentation, and if you have any ideas for the future presentations from other people in the bank as well. But thank you for participating, and we will see probably again in a month with another presentation. And bye bye.